Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at adding a set pixel method using bit shifting to our screen class. And this time I'm not going to type out the code in front of you, I'm just going to show you it. The reason being that I recorded this video once, then somehow accidentally deleted it. Meanwhile I'd recorded all the other videos, so I don't want to end up typing something different in this video on the second recording to what I typed previously. So just to make sure I don't, I'm just going to talk you through this. One thing that we need to do before we start with setting pixels is we need to add an update method to the screen class. And what this is going to do is, let's take a look at here I'm calling the method, and it's within the while loop, the game loop, if you like, in main.cpp. And after we set pixel data, we're going to go on to look at this in a minute. But after we set pixel data, we will want to update the screen, take that data and put it on the screen. So we need to, if we look at the previous version of this, we've got in init, we've got this stuff here that's actually taking the pixel data basically and putting it on the screen. I've also got some code here that's setting some pixel data. If we look at what we need to change this to in screen.cpp, we need to get rid of that stuff that was setting the pixel data. So we need to get rid of that stuff there. We don't need that. This is the original version before you change it now. And this stuff here needs to go in a separate update method. So I'm going to put that in a separate method here, screen.update. So you need to create that method, obviously add the prototype to screen.h. So in screen.h we've got a prototype for an update method. In screen.cpp I've implemented that method, and I've moved this update texture, render clear, render copy, render present into the update method. And then in main.cpp here I've called screen.update, and that means that if before that we go on to implement this stuff and set some pixel colors, then after they've been set we can then update the screen here. So we can go to our screen.h. Let's get the right workspace here, screen.h, and we can add a method to it called void set pixel, and that's going to take an x and y coordinate to set the pixel at, and it's going to take red, green and blue values, which are basically unsigned chars, but we'll use the SDL type uint8 just for consistency really, and this is guaranteed to be it's an unsigned 8-bit int, or in other words an unsigned char. So once we've added the prototype here for the function, we can go to screen.cpp and we can add in the framework for that function, for that method. So we can just add it in the implementation as we do normally. Then we can take a uint32, which is guaranteed to be a 32-bit int on all platforms. It's an unsigned 32-bit int, which is again is an SDL type, but you often see types like this defined for various APIs. And we can do exactly what we did in the last tutorial. We add on a red value in this case. In fact, we need the red first for SDL here. At least for my system. If it's different on yours, you will have discovered this by now. But first we need the red, then we shift it 8 bits like we saw in the last tutorial. Then we add the green, then the blue after shifting. Finally we shift and we add the alpha value here, which we're going to set to FF, which means opaque. And then we just have to set that value in our buffer. So to get the right pixel, we have to multiply y by the screen width, because we have to say we want to go 10 rows down, then we've got 10 rows there of pixels, and each row has the screen width. So if we multiply this by the y value, we'll go down to the right row. We then add x, which is like the column value. So once we've gone down to the right row, we have to move to the right by whatever x is, and this is a a way of going from an XY coordinate to actually getting the index into the buffer here, where the buffer represents all the pixels starting from the top left corner, reading across, then going down to the next row, reading across, and so on. The buffer's stored in that order. And this transforms our XY coordinates to an index into the buffer. And we just set that equal to the color. Now to use this, we go to main.cpp. Let's comment this out for a second. So let's go to source and add comment block, add block comment here. So if we then use this and do screen.setPixel, let's set it in the middle of the screen. So X, in this case, I've got an 800 by 600 screen. So we can set it at X400, Y300, and let's set all the color values to the maximum, which is OXFF in hex or 255 in decimal. And we then get a single white pixel on the screen, which hopefully you can see here. So let's go back to Eclipse. And what we can do is go on to add a block of colors. Let's uncomment this here. So source, remove block comment. So I can iterate through all the Y values, and then for each Y value, in other words, for each row, we iterate through all the X values in that row. So by having a nested loop, we can visit every pixel in the screen. And the Y, of course, goes up to the screen height. Well, up to one less than the screen height, because it starts at 0. And the X iterates from 0 to the screen width, one less than the screen width again. Then we can call screen.setPixel, the method we just created, pass in X and Y and add in some values. So I've added 128 for red here, 0 for green, and 255 for blue, which gives us a purple color. So now we've got a big block of purple with a single white pixel in the center. So that's it for this tutorial. I'm keeping my fingers crossed that I've not deleted any more videos, and I'm going to put these in the right order so you'll be able to follow this through, and I'm going to attach this source code to this video as well. So well worth having a go at that. Try it out and implement your own set pixel method. You might even think of a slightly different way of doing it to me. As long as it works and it's safe, then it's good. And then try setting just one pixel, and then try setting a whole block of color as well. So until next time, happy coding. Oh, by the way, this shouldn't be there. Let's just delete that. Okay.